Okay, make sure that you have a textbook out and you're looking up theorem 9-19. Draw a picture to get that one defined and label that picture. And then once again, a quick review of the midpoint and distance formula. That'll help us start out in today's proving using coordinates, the coordinate plane here. Kind of an extension off 9.5. Okay, so if you have a trapezoid, okay, and you're dealing with, what's theorem 9.19 say? Go ahead, Nick.
Mid-segment of a trapezoid is parallel to the bases and half as long as the sum of the length of the bases.
Good, so the mid-segment of a trapezoid. So we have this mid-segment, it's parallel to the bases. First, you should know what a mid-segment is. Mid-segment connects the midpoints of the two legs of the trapezoid. Okay, it's parallel to the two bases, and then it's half of, if we call this base 2 and base 1, it's half of that length. So if we add base 1 plus base 2 up, combine those two, and cut it in half, okay, that's going to give us this mid-segment. All right, so it's parallel. M is parallel to both B1 and B2. And it's half the length of the sum of those two. All right, so you'll be able to use that in some of the coordinate stuff we're doing today. Any questions there? We'll actually hit a proof on it later. So the midpoint formula. What's the midpoint formula again?
y1 plus y2 over 2, comma, x1 and x2. And then y1 plus y2 over 2, all in parentheses.
Okay, so the midpoint formula, we're adding the two x's up and dividing it by 2, and the y's up and dividing them by 2. So we reviewed that in our last lesson, hitting it again here. Distance formula, D equals, someone that hasn't participated yet. We got, I can't see who that is. Jordan.
X2 minus x1 squared plus y2 minus y1 squared, all under like square root.
Unbelievable. Put squared there. Okay, x2 minus x1 squared plus y2 minus y1 squared. Good. And square root of that. All right. Any questions on those? Okay, well, let's see how we're going to apply this stuff. I want you to take the other sheet you grabbed on the way into class, okay? And we're going to start on this right here, the first part. This is the front page. I know they're not numbered, but we're going to go with this being the front page. Okay? Now, your assignment's not a large assignment tonight, but it can be a bit confusing, just like 9.5 is a bit confusing. Okay? Please note that we have a test on Wednesday. Okay? So we get a practice test tomorrow, test on Wednesday, and then Thursday and Friday we have some review material we're doing. Okay? Questions? All right, here we go. It says complete the coordinates for each figure, then use coordinate geometry to prove that statement. First thing, I want you to find what A and C are. Work with your neighbors. Ready, go. Your attention back up here. I'll give you A, the difficult one here. A is the ordered pair 0, 0. Yes. Okay. C. Go with C. C, remember, this length and, well, this length right here from this point, from A to here, that length is a length of how far? 2b, yeah. This is x coordinate of 2b right here, meaning this length is 2b. Goes from 0 to 2b, so that's a length of 2b. I know that's weird because that's not a numeric value, but it means 2 times the length of b gives us that actual length. Okay, 2b, that's not a negative sign there. It looks like one. But. Okay, and then that means from here to here is a length of 2b. Okay, these two lengths are the same. So if I extend this down, which would give me my x coordinate of C, this length, maybe I'll just keep extending this. This length right here is the length of 2b. So I've traveled from point A. If I'm trying to figure out where C is, let's extend this down again. I'm traveling from this point A all the way out to point D. How far did I go to get to point D? 2A, right? That's the coordinate of 2A. So I've traveled from here all the way to here, which is a length of 2A. We know that because point D has a coordinate of 2A. And then I have to go an extra 2B. So that means this coordinate for C, the x coordinate for C is 2A plus 2B. Okay, how many got that? All right, and so from here to, we're going all the way up here, right, to get to point C. That height from here to here, well, what other point is at that same height? Point B. And it has a height of 2C. So that's a length of 2C, which means this is 2C here, which means this is 2C. 2B, 2C. Cool? All right, well, let's do what it says now. It says, given parallelogram ABCD, prove that AC bisects BD and BD bisects AC. Now, if you look at that and you're just like, huh? It can be like a daunting task. First thing you need to do is have a plan of attack. How are you going to prove, understanding what they're asking, how are you going to prove that this AC bisects BD? Okay? And BD then would bisect AC. It cuts them in half. I want you to work with your neighbor. Come up with a plan. What are you going to do? Okay, wrap up discussion, please. You got about 10 seconds. Okay, can I get your attention back up here? Hey, I tried to clean this up, so I put a new sheet here where I got rid of all the lines. If we know that AC bisects BD, okay, that means this point right here is what? It's the midpoint of each of these lines. Very true. Okay? It also means that BD's midpoint should be the same as AC's midpoint, correct? Okay, now that's a hint to what my plan would be. Anyone have a plan that they decided they would be going with? Jody, what did you get?
If you prove triangle DEA and CEA, then you can use, well, like the lines would be bisecting because they'd be congruent,
Okay.
like on each side.
Okay, the parts would be congruent, so, okay. So you could try to go through triangle proofs. Okay, we'd have to prove the triangle's congruent some way. All right? Anyone else? Nick?
You find the midpoints of each line, and then if they're equal, then you just put that they bisect each other by definition of bisecting.
Okay, so if I found the midpoint of this line and the midpoint of that line, and if they have the exact same midpoint, the coordinates are the same, then they would bisect each other by definition of midpoint. Very true. Hey, how many of you chose to try to deal with triangles to do this? Okay, how many thought, well, if I could just find the midpoints, that would work out? Okay, how many of you couldn't come up with a plan? You're like stuck on it. And that's one of the tough things to do. Okay, whenever you see the word bisects, and especially if you're dealing with coordinate proofs, think of using the midpoint formula. Okay, there are three things that I keep asking you guys. I asked a lot of 9.5 and 9.6. I said, what is the midpoint formula? What's the other formula I've asked for? Distance formula. And what's the last one? Oh, spell formula right. Okay, and then the slope formula. Those are the ones you're going to be using the most when you're dealing with coordinate geometry. Okay, so if I'm thinking, well, could I use one of these three formulas? Yeah, the midpoint formula works out really well here. You could try to deal with triangles. It would be much more complex, though. Okay? All right, well, let's go ahead and try that. I want everyone to find the midpoint of AC and the midpoint of BD. Okay? Go for it. So our plan, for those of you who didn't write down the plan, our plan is to find the midpoint of each and see if those midpoints, if they have the same midpoint. If they do, then the lines bisect each other. So the plan, it's always good to have a plan. Our plan is find the midpoint of AC and the midpoint of BD. If the midpoints are the same, then AC bisects BD. And as I was walking around, I saw some of you had like the 2-column proof on your paper. This is as close as we're getting to a paragraph proof. Okay, we won't actually, when we're doing coordinate geometry, we're not going to fill out a 2-column proof. We're going to do more of a paragraph proof approach. Here's our plan. We're now going to go through the work of finding midpoint of AC. So I'm just going to show the work here. AC, we know that our formula for midpoint, we take our x values, x and x. Okay, so you call this one x2 and x1 and y2 and y1. Right? I know they look weird, but we have x2 plus x1, or we just add them up, so we get 0 plus 2a plus 2b. All over 2. And our y-coordinate, 0 plus 2c, all over 2. It gives us, if we simplify it, 2a plus 2b over 2, comma, 2c over 2. Can we simplify that any further?
Yeah.
Yep, what can we take out?
A plus B.
Yeah, you get the a plus b by canceling 2's, right?
Yeah.
Whenever there's addition in the middle, you've got to cancel from each part. You can't just cancel it. If this was 2a and that was just a b, you couldn't cancel there. Okay, really what you're doing up there without doing it is you're doing factoring. You're pulling out a 2 and you're saying a plus b. And you're canceling that 2 with that 2. So you're left with a plus b. Okay, here, and you're canceling there, you get c. So a plus b, c. That is the midpoint of AC. Okay? Now, how many found the midpoint of BD? Did you get the same thing? Yeah? Okay? So if I'm calculating that midpoint of BD, okay, midpoint of BD, we're going to have, we're adding them up, we call this one x2, y2, x1, y1. So we'd have 2b plus 2a. And then 2c plus 0. Okay, once again, we cancel. We think of this as like 2 times b plus a over 2 and 2c over 2. And that gives us a plus b and c. All right. Very good. They have the same midpoint. Nick?
You want us to write down a plan?
If I were you, I'd write down a plan every time. You don't have to write it here. But the next problem, you're going to approach the same way. You're going to have a plan. you're going to show your work, and then you're going to write your final statement, your conclusion. Okay? So I want everyone to write down how you know that AC bisects BD, and you can reference your work here to help support your evidence. Okay? It's like a claim support. Explain, yeah. Good job. Way to complete it. Claim, support, explain. Our claim is what? Yeah, AC bisects BD. Our support is what?
The midpoint.
The midpoints. And our explanation? Well, that's what you're filling out. Yeah, the final part here. Okay? All right, so we have two of them here. We'll do this one. All right? AC bisects BD, and BD bisects AC because the midpoints of the line segments are the same. Good. And if you wanna beef up that reasoning a bit, you could even list the midpoints. Okay, that's good. Any comments on that one? All right, let's try the next one here. AC bisects BD, and BD bisects AC because the midpoints are equal for each diagonal, which proves that the lines bisect each other. Good, and you can give this the midpoint as well. Well done. Any questions on that? Paragraph proof there. Okay, moving on. Let's try letter, or actually this next one, I guess we don't have a letter or number by it. Okay, find the coordinates. Okay, let's see if we got the coordinates here. So letter F. What do we got? Three? Negative BC. How many got negative BC? Can we get a second there? Okay. All right. And you're saying, why is it C?
Because it's the same as point G.
Good. It's the same level as point G, and C is our y-axis, which represents our height of it. Okay. Good. How do you know it's negative B?
Because it's on the opposite side of the y-axis.
Good. It's reflecting here, right? Okay. This is a length of B, which makes this a length of, well, it makes it a length of B, but you're going back B, so that makes that negative B. Good job. Okay. How about point E? Hold on, Maddie. Yeah. Negative A0. I'm trying to call on as many people as I can. Negative A0, well done. Okay, same distance as this, right? This is A. This makes A also. It's just we're going backwards, so it's negative A. Okay? What's this point?
0,
0,
0.
0. Now, it doesn't actually, that was an easy one, but it does say complete the coordinates for each figure. And this one, if we would have completed the coordinates for point E at the very beginning, it would have made that problem real easy, right? We just didn't do that. Okay, here we go. All right, we've got to go through the proof now. Trapezoid, it's trapezoid FE. Okay, we've got the givens. EG is congruent to HF, so EG congruent to HF. So diagonal congruent to diagonal. Do the triangles help out tons in these proofs? Not really. Okay, try to use one of your formulas, distance, midpoint, or slope. See how that would help. Try to come up with a plan with your neighbor right now. Wrap up discussion here. What are you doing?
Thought there was some, like a spider in my head.
There might be. Creepy. All right. What's our plan? Sew in the hat. Lee, what do you got?
Find the distance of each diagonal using the distance line.
Okay, so if we find the distance of each, then we know the length, and if we know the length, then we know if they're congruent or not. Right? All right, very good. Hey, sounds like a plan. So let's calculate the distance of each of them and see if the distances are equal. Go for it. All right, wrap up discussion. Hey, guys, I saw a few problems when I was going around. So let's go through this. We are taking x2, y2, x1, y1 here. Okay? Oh, you guys can't see that. You guys got to tell me if I'm off the screen. Way to go, Eli. Once again, a maturity thing. You'll eventually grow out of it. Okay? All right, so we go e to g, x2. x2 is negative a. x1 is b, so we're subtracting those two things. And we're squaring it. Plus y2 is 0. And y1 is c. And squaring it. Now, here's where I saw some of you making mistakes with your simplifying. First of all, when I square this, I have negative and negative. I can take out a -1 from both of these, right? Okay, this is where a lot of algebra comes into play. How many remember factoring? Okay, let's take a -1 out of these so it doesn't look as weird. Good. When I take a -1 out, I now have a plus b. How many are following me there? Okay, I divided each by -1, so I only had about a quarter of the class following me. So, are there questions on what I did there? Nick?
So if you take a -1 out, how would that? Take the -1.
All I'm doing is dividing by -1. So when I divide a by -1, it gives me, or negative a by -1, it gives me positive a. When I divide negative b by -1, I get positive b. Okay, so I have now a plus b. Okay, and the -1's out here. If I distribute it back in, I get back to negative a and negative b, right? How many are with me? The whole point of doing that is to make this look more, a little more normal, I guess. A little easier to deal with. Yeah?
But instead of doing that, could you just skip that step and just have it be squared so it can be positive?
You could have it be squared, but the problem I had is when you guys were squaring that, many of you are making mistakes here. That doesn't become a squared b squared. That's not how that works. Okay? When I square this, I don't just get negative a times negative a and get a squared, and negative b times negative b and get b squared. You guys, if you recall back to, let me just put that here real quick. You recall back to algebra, when you square something like that, that means negative a minus b times negative a minus b. How many recall that? Okay, and then you multiply like this, right? You get a squared that way, and negative or positive ab, and positive ab, and positive b squared. So you don't just get a squared plus b squared. You have this piece in the middle, that 2ab's in the middle. Okay, how many recall that? That's a key, like, I expect you to remember that in trig next year. Okay, that's a key piece. That's something we cover again this summer. All right? So the reason I don't just do that here is because mathematically that's not right. Okay? Hey, Trevor, you got to move. Either you or JJ. One of you guys move up here. Hustle up, though. You guys have 10 seconds before I kick you both out and give you paragraphs. Do me a favor and just don't sit by each other in class. Like, find someone else to sit with because you can't handle it. And the whole class has to wait on you. All right, so now I'm squaring this. That gives me negative c. 0 minus c is negative c. So negative c squared is? It's c squared. Okay, oops, I forgot to finish this. Sorry, got interrupted there. So we got to square that. What's -1 squared? It's 1, right? And here we have a plus b, quantity squared. And we're going to leave it like that. We don't need to worry about the 1 out in front because it's implied. So that's what we end up with. Now some of you may have ended up with that already. You're like, well, that's how I did it, and I just did it another way. I subtracted this one from this one, and I got a plus, which you could have. If you would have switched your x2 and your x1s up here, you could have had that. How many got that for EG? Okay, let's go on to HF. Actually, any questions on that one? Yeah, Gracie?
Can you simplify it to just say a squared plus b squared?
Oh, that's a good question. Can we just, like, you mean get rid of the root?
No, I mean,
Oh.
like right now, could you distribute that?
It would still do the same thing it does over here. It give you a squared plus 2ab plus b squared. And the other mistake I saw is some of you just canceling this radical and that square and that square. You can't do that. It doesn't become a plus b plus c. You have to, and before you can get rid of this radical, you have to combine everything inside here. There are implied parentheses in there. Okay? So Bennett, you should probably turn around now and pay attention. All right. So we got EG. Let's go HF here. So we're dealing with distance of HF. We get square root again. We're going to go, I'm going to call this one x2, y2, x1, y1. Okay. So x2, y2, x1, y1. And we'll go through it. Okay, what's x2? A. Thank you. What's x1? Negative b. Oops, that's supposed to be minus again. Okay, plus, what's y2?
C.
No. Y2 is 0. Y1? C. Okay, we square that. That ends up giving us, that becomes a plus, right? Okay, two negatives make that positive, so we get a plus b squared and c squared. Hey, distances are the same. So, what would a final statement be? Oh, someone new. Hasn't participated yet. Go ahead, Bennett.
The EG and HF are congruent because, according to this formula, they have the same distance.
Okay, yeah. So we could say EG and HF are congruent because they have the same distance, according to the distance formula. Okay, so make sure you have that final statement. You may even put in the length, right? The length of square root of a plus b quantity squared plus c squared. All right. I think you got it. Okay. Very good. We have some stuff on the back. I want you to take a look at this guy right here. Okay. Should be a similar type of problem. Okay, go ahead and tell your neighbor how you're going to solve that one. What's your plan? Don't worry about finding the coordinates yet. Just tell your neighbor the plan. All right, give me a plan. All right, give me a plan. All right, can I have your attention up here? Thank you. Now can I have a plan? Someone that hasn't participated yet today. Jody, you participated at the beginning. Trevor.
Find coordinates of y, b, and n, and then do the distance formula.
Okay, use the distance formula of like this length and this length. Okay, and this length. After we find the coordinates. All right. Very good. Lee?
Actually, you only have to find the distance of MP or PN because since P is the midpoint of MN, then the MP and PN are always equal.
Oh, okay. Very good. So since P is the midpoint of MN, If that's true, then what's congruent already?
MP and
P and
MP and PN, right? All right? So we can prove that PO or OP, we can show OP is congruent to either PN or PM using the distance formula. All right? Very good. What's the coordinates of P? Everyone go ahead and figure that out, please. Okay, so the coordinate of P, we add these up. 2B plus 0 is 2B divided by 2 is B. And 2A plus 0 divided by 2 is A. Everyone get that? Okay. So, find the distance of OP and PN to show they are equal. Everyone go ahead and find those distances, please. All right, so I'm borrowing Emily's here. All right, the distance of OP, got B squared plus A squared, plugging in our points. Distance of MP, also B squared plus A squared. How many got B squared plus A squared? Can we cancel the roots in the squares? Nope. Okay, so let's write a final, Eli.
Do you have to have them in parentheses still or no?
No, you don't need to have them in parentheses anymore. Okay, let's write a final statement there. How do we know everything's congruent? Let's write our final statement up for that. Okay, so we have all of our work, and Jody's got this. MP is congruent to PN, is congruent to OP because the distance between MP, PN, and OP are all congruent. They're all the same, which is B squared plus A squared. Good. And you'll notice that this says equal up here. Should say congruent, so we could add those little congruent marking. All right. But well done. Nice job, Jody. Any questions or comments on it? Okay, take a look at this one. Right? Find the different coordinates. Jody's done some extra markings already. All right. So find the coordinates of those points there based on what they've given you. All right, I'll give you G. It's 0, 0. How about E? What's E? 0, 2C. Same level as this, so that's our Y value. How about D?
2B.
Okay, how about R?
Negative 2.
Negative 2B, 2C. Good. Okay, it's the same distance as this here, right? Okay, how about T? Negative 2A, 0. This is our midpoint, right? It says that they're midpoints, so this is midpoint, so add them up. 2A plus 2B divided by 2 is? A plus B. Okay, comma. 0 plus 2C divided by 2? C. And that makes this negative 2A plus negative 2B divided by 2? Negative A minus B. And then C. 0 plus 2C divided by 2. Okay, we need to find out that this is a rhombus. What is our plan for doing that? We're not going to do it here, but what do we need to do? Hoping that's becoming easier. JJ, what do you got?
I'm gonna do the distance formula for F, G, D, G, T, E, and E.
Good. So a good plan would be to find the distance formula for each of these, right? And once we find the distance formula, add them all. They all make sure that they're all equal. Once they're all equal, we can make a statement. So here is the work I've done on that one. We're running out of time, so if you want to do that one at home, you can. But there it is. All right, and remember, you can pull that up online at home, but there you go. It's quite a mess. All right, hey,